Okay, so talking about this course is about Azure DevOps and talking about prerequisites. Now, there are also some prerequisites if you want to go for the certification. Okay, because talking about these trainings, of this training is of 5 days. You can attend these trainings even if you don't have experience with Azure. But talking about certification, in that case, you need to have your prerequisites cleared. So this course is AZ400 as your DevOps engineer, and successful learners will have prior knowledge and understanding of the following: cloud computing concepts. You should be familiar with the cloud computing concepts. What is PaaS? What is SaaS? What is IaaS? And you should have knowledge about Azure administration and Azure development, which means you should have knowledge about AZ104 and AZ204 with proven expertise in at least one of these areas. This means that if you want to get the certification, it's okay if you get only one certification. If you're 104 certified, if you have the 104 certification or 204 certification, any one certification you have, you may go with the AZ 400 exam. Because AZ 400 is your expert level course, and 104 and 204, these are the associate levels. And Microsoft has their prerequisite mentioned. But in order to get your Azure DevOps Engineer badge, which you get, for that you need to have your prerequisites cleared. So you should be either 104 certified or 204. And this depends on your background. Because AZ204 is about development, Azure Developer Associate. And 104 is about the administration. So in 204, you deal more with, in your exam also, about the code snippets and mainly, about .NET. In 204, you work with the services and then you work on that how to integrate with these services in your application. On the other hand, 104 just talks about simple administration. If you have a resource, how to create it, how to take backups. So this again depends on your background, that what you want to go with. And if you don't have any certificate, 104 or 204, what you can do is you can take your AC 400 exam. Still, you can take your AC 400 exam, but the thing is that you will not get the badge. Even after clearing 400 exam, you will not get the badge in your profile. You know the badge which you get, AZ4 as your
Your
DevOps
DevOps
engineer.
engineer.
After that, also you have to complete your associate level certification. Like you need to clear, let's say AZ204 or AZ104. Once you clear it, after that you are going to get your badge on the profile. So that's how it works. Now, Microsoft Learn. Get most out of your Microsoft Learn profile. And here they have given the link. What is Microsoft Learn profile? Okay, let me go to Microsoft Learn. Okay, this is your Microsoft Learn, where you can get all the documentations, materials, you can get them all for free. Now, in order to track your progress, how much you have completed, how much you have read, in order to track that, you can sign in. If you don't have a profile, you can create one. So let me sign in here. Okay, here I'm signed in, and you can see that I have this level, when you read the content, when you complete the content, your level is increased. And currently I'm on level 12. Okay, go to your profile. Okay, click on it. Go to profile. After going to the profile, you will see some badges and trophies added. Now, in your Microsoft Learn profile, if you will go to achievements, you will see that I have completed some modules and learning paths. So, learning path consists of multiple modules. So, let's say for AZ 700, we have a learning path. You click on it, okay, and you will see all the content. You will see all the modules which are covered in this learning path. And modules have units. Like, I want to know how to configure public IP services. Click on it. Read this content. Once you complete the reading and you complete the module, your level will be increased. And then, if you go back to your profile, here you will see badges and trophies added. So, in order to track this progress, you have these badges and trophies. What all you have completed. So, here is your achievement. So, you have completed this learning path along with the date that it was completed on this particular date. So, anything that you want to study, you can search it on Microsoft Learn. I want to study about Azure and I want to specifically know about app service. Azure app service documentation I want to read. App service plan I want to read. I can find the documentations here. I can also find the trainings. Okay, so let's say app service. This is the documentation, but you can also select on training. And here you have this training, AZ204. Okay, so in which you can have the modules and learning paths. You can complete these modules and learning paths. Can increase the level and you can have the badges and trophies. So learn profile tells that how much you have studied, how much you have read, and what all certifications you have. Because when you register for exam, you create a certification profile, okay? And that you can create with the help of the same account. Here you can have your information of all the certificates. About active certification. And here you also get the details of modules that you have completed. Remember, I've shown you that modules that you complete and you get trophies and badges added. So here also you have that detail of modules completed under the transcript. And anytime you want to share, you can share the link of this transcript. You can share it on any public platform like LinkedIn. You can add it if you have, let's say so many active certifications, AZ204, AZ, let's say 400, AZ305 for DevOps. Okay, and those certificates are required for a particular job profile. So you may also share the link. You may also have this link in your resume. So that's what your Learn profile is about. So I'll just share this link with you. If you don't have an account, please create a Learn account and using your personal ID, not your organizational account. Because in case you leave your organization, In that case, you might lose the access to your organizational account, which will create a problem. So that's why go with a personal account. In case you want to have your organizational account, add it as a secondary. In your profile, you can add a secondary mail. So there you can add your Wipro ID if you want. So using this, you like access your course material. How why to become certified? Because 92% of certified IT professionals feel more confident in their abilities. Then they have given this marks distribution. Find in the exam page resources to help. Watch exam prep videos, review study guide, demo the exam experience, take practice assessment. So where you can find all of these? In the exam page resources. So let me share that as well. Here you can find everything, even your entire syllabus. And here you can sign in with your learn profile. You can sign in and you can track your progress. So if you talk about all theoretical content, if you want to have the theoretical content, you can find it over here. Okay, so these are all the learning paths that we are going to cover. And here you can watch these exam prep videos, study guide. Now to stay updated with the marks distribution, you can go to the study guide. See, design and implement process and communication covers 10 to 15%. Design and implement appropriate metrics and queries. Design traceability. All these topics are covered here. Then design and implement a source control strategy. Covers around 10 to 15% of questions. Then we have design and implement build and release pipeline, the most important one. Yeah, and it also has 50 to 55% of weightage. Then develop a security and compliance plan 10 to 15%. So this is your study guide. So these were the important links. I've shared them with you. So anytime you want to know about your entire syllabus, you want to know about the distribution, the marks distribution, you can come up here. Now let me also give you the idea of how we are going to. Okay. You know how we are going to continue the sessions. So today is Monday. So we have the sessions till Friday. So we have got 5 days. 5 days, 20 hours. Because each day will get 4 hours. So in total, we are getting 20 hours. Now the thing is that, you know, originally this course is for 32 hours. This course is for 32 hours. And we are only getting 20 hours. So right now, it won't be possible for us to get into detail of each and everything. I'll try to cover everything along with the demos, but we'll not be able to like cover things in very much detail. And also, you won't be able to perform the labs during the session. You may cover the labs afterwards once the session is over. But because we have very less time here, so you cannot perform the labs during the sessions. After the session, you are free to do so. And we'll have 4 hours each day. So during the session, we can also take a short break because we cannot like sit for continuously 4 hours. You cannot listen for continuously 4 hours, and I cannot speak for like continuously 4 hours. So in between, we'll also try to take a short break, maybe after 2 hours. So that's how we are going to carry these sessions. I'll just remove all of this. Now, how to access the recordings? As I have already told you that these sessions are going to be recorded. So in order to access the recordings, you will take help of LET portal or student portal. You can call it as anything, student or LET portal. Under the LET portal, you're going to find the recordings, class recordings. And these recordings are going to be for 15 days. In case you want to confirm the expiry date, when the recording will be available on the portal, along with that, the expiry date will also be mentioned. So under the class recordings, you will find each and every recording, and along with the recording video, you're also going to see the expiry date. Yeah, so that was about recording. And also in your LET portal, you can attempt the quiz. Okay, you will have these module wise quiz which you can attempt. So I'm going to give you the access to this LET portal. This is your link, and username will be your official email ID, and this is your password. This is actually your one time password, not the permanent one. What you can do is you can go to the LET portal, and on the right hand side, on the top, you can find an option update profile, wherein you can just update your password. You can even add a secondary mail ID. Okay. So from there you can update your password. In case you forget to update the password and you have like logged out, no worries. The next time you can click on forget password and then you can reset your password. So that was about your LED portal or the student portal, anything. Right. All right. So let me also give you a brief description of AZ400 learning path. Okay, so here we will first of all start with the very first learning path, development for enterprise DevOps, in which we are going to talk about what is DevOps, why we need it, what is the transformation journey. Then we'll talk about planning using your Azure boards, GitHub projects also you can use, design and implement branch strategy, what is branching, what is Git, everything will be covered, repos. So basically about your version controlling. Okay. So those things will be covered here. What is Git hooks? What is inner source? How do you work with repositories? What is technical depth? Then we'll move to the next learning path, which will be about working with pipelines. Pipelines, CI pipeline, CD pipeline, classic pipeline, YAML pipeline, then implementing the release strategy. What is release strategy? Okay, those things we are going to cover here. Then security. Implement a secure continuous deployment using Azure pipelines. So, what are the different deployment strategies, modern deployment strategies, which can be used, for the pipelines in the CD process? Then about infrastructure as code. Then about dependency management strategy. Implement continuous feedback, which is more of like theoretical things are involved here. And then finally, or implement security and validate code bases for compliance. This is nothing but your DevSecOps, wherein you talk about the security, how to secure your pipelines. Those things will be covered here. So this is your entire learning path. But the thing is that we will not, simply follow the PPT and read each and every slide. Because here we have to focus more on the, hands-on, on the demos, on the practicals. So we'll mostly, work with just portal and will not go to each and every slide. What we'll do is we'll take help of these notes over here, which I have created in a more structured way. Because let's say after CI, they are simply talking about CD, not, mainly not about classic pipeline and then YAML pipeline. Sometimes things are mixed up. So, but we will follow a proper path. We'll first cover the classic pipeline and then we will cover the YAML pipeline. CI CD of classic and then CI CD of YAML. And I have included, these more description about here. Let me open the PPT over here for module 1. Just give me a moment. Okay, now let's have a look at the very first learning path, in which we will be talking about, what is DevOps. From there, we have to start Introduction to DevOps. This is our module 1. And then we'll move on to planning, how to use Azure boards for planning. Then about version controlling. This is Azure repos we will be working with. Now here you can see that in the slides, you have a very, brief discussion. What is CI? Just 3 lines are there. CD, 2 lines. And then version controlling, agile, cloud, monitoring, logging. These few lines are covered here for containers also. So what we'll do is we'll go back to the notes to discuss the things in detail. Now, if you talk about this, let's say CI, CD, and version controlling, actually, these things are discussed in detail in the later modules. This is your introduction. So, if you feel that you are not confident about pipelines in this module, no worries because pipeline we are covering it in separate module. Okay, so let's go to the notes and see the very first topic, which is Introduction to DevOps. What is DevOps? So, what is DevOps according to you? So, official Microsoft PPTs are not allowed to share, but I will share the notes. Notes I will share on the last day. Okay, so what is DevOps? Actually, DevOps is a software development practice which combines the words development and operation. So basically, your DevOps is a culture. It's not about one tool, it's not about any one specific tool, it is actually a culture. It's about the set of practices. DevOps is important because it helps businesses deliver high quality products faster, respond to market demands quickly, stay competitive, innovate quickly, and respond to customer needs more efficiently. So, DevOps practices they include team empowerment, cross team communication, technology automation. So, DevOps is a culture that talks about your practices and principles. But the thing is that why it was introduced, because DevOps was originated around 2007. But why was it originated? What was the story behind it? So earlier, when you worked in your organization, there had two teams. One was the development, and the other one was operations. Now, in your development team, what was the job of development team? The job of the development team was to plan the product, plan your project, then code, build, test. That was all the responsibility of development team. And for the operations team, it was your actual deployment, high availability, ensuring high availability, taking backups. All this was the job of the operations team. But now it was also following the silo based development, which means that there was no proper communication between the development and the operations team. There was no communication. So what would happen that development team would do its work and then operations team was responsible for deployment, but there would be some shortcomings, let's say. Any problem arised. So in that case, the operations team would say that we have done our work properly, and this might be the issue from the development side of the development team. The development team would also say that we have done our work properly, that there might be some problem with the operations team. So, this blame game would go on. So, there was no proper communication between these two teams, and hence, as a response to this traditional software development model, DevOps was originated. Okay. So DevOps integrates these disciplines into a single continuous process. So hence we have the DevOps. What are the goals of DevOps? We talk about goals. So first of all it is speed. Okay, I'll say that these are the key goals. Speed to deliver your new features and fixes and updates faster. If you have a feature available, you want to make it available quickly to the end user without wasting any time. Second is your second key goal is to focus on quality. It's not like you are increasing the speed, so you'll compromise on the quality. DevOps also talks about managing the quality. Third is reliability. And fourth is collaboration. Fifth is efficiency. Speed, any feature that is available, you want to make it quickly available to the end user. Quality, to ensure that you are incorporating continuous testing, monitoring, feedback loops. You're taking feedback of your end users, and if anything has to be improved, you're improving it. So you are not compromising with the quality. Reliability, you have to ensure that your systems are always stable and they are performant. There should be no downtime. You should reduce the downtimes and any kind of operational disruptions. Any kind of operational disruptions should not be accepted. Fourth, improve your collaboration. So you should have culture of, a shared responsibility between the development and the operations team. So focus on collaboration also instead of having this silo based development where the teams do not communicate with each other. Focus on efficiency. You also need to optimize your resource usage. You have to reduce the manual work because if you have a lot of manual tasks, repetitive manual tasks, it will decrease the efficiency, increase the time, and hence it will slow down the speed. So you also have to work on reducing these manual work. And how? By including more automation. So you need to have these automate your repetitive task. So these are your key goals of DevOps. And in order to achieve these key goals, now the thing is that you also want to achieve them. So now to achieve these key goals, DevOps has some key principles. To achieve these goals. So these are mentioned here. These are all the key principles: CI, CD, version control, agile, monitoring, logging. This is also called as your transformation journey because if you are working with your traditional uh, approach, You are not working with any kind of DevOps practices at this time. So if you want to work with them, you need to follow proper transformation. You need to transform everything. If you're not working with the pipelines, you need to have new pipelines. You'll create the pipelines from the scratch. You're not working with infrastructure as code. You will select the infrastructure as code tool and then you will start working on it. So proper transformation journey will be there. So you need to understand this journey. So let me do one thing. I'll also add the diagram over here. So if you have a look at DevOps, it is actually represented by the infinity sign. Here it is represented by your infinity sign. Now we have two things here, CI and CD. See, it is represented by this loop, infinite loop. Here we have CI and here we have CD. CI focuses on the development and CD means operation. So whatever the work was, of this operations team, like deployment, monitoring, backups, high availability. So here, starting from the beginning, first of all, you plan the project, code it, you build it, you test it, and then you release. You finally go for deployment, operate, and monitor. Take the feedbacks, then again improve it. So this goes on. So two main things are there, CI and CD. Now, what is CI? Continuous integration is the ongoing merging and the testing of your code. Ongoing merging. So what happens that here, what will happen that anytime any developer has made a change to the code, at that time only it will be tested. So what you will do is you will automate this workflow. So after you have merged the code, it will be built, it will be tested to find any kind of defects early in the stage. Instead of collecting multiple commits, so you have this commit 1, commit 2, commit 3. Okay, multiple commits are, gathered and by different developers. You collect it and then you test it manually. So that's not what we want. What we do is anytime the change is made, anytime changes are made, at that time only it will build your project and it is going to test your changes which you have made. And you will get the report, and based on that, you will decide that whether you want to proceed with the deployment or not, or you want to reject it, or you want to approve it. So, this is done in order to find defects early in the stage. This is your CI. Now comes your CD, which is continuous delivery. Continuous delivery means that you are preparing all your changes for the deployment. So, here this is your CD part. First of all, you're going to prepare all the changes for the deployment. You might include some manual intervention in between. A person is going to approve it, then it will automatically be deployed to your target. Target can be your physical servers, they can be your uh, PaaS solutions in Azure or in any other, cloud provider, AWS, GCP. Then you operate on it. You are continuously monitoring it. Anytime any failure or anomaly is detected, you take action. So this is your CI and CD. But is DevOps only about CI CD? No, it's not just about the CI and CD. It's more than that. CI and CD were the two core concepts. CI and CD is ultimately used to achieve speed and manage efficiency because you are automating your repetitive tasks and you are increasing the speed also. Anytime changes are made, so you can say anytime a new feature is available, you will quickly build, test it, and prepare it for the deployment. So, this is done in order to achieve two main goals of the DevOps, which is speed and efficiency. Next is version control. Version control is a software development practice that tracks and manages the changes to the code and other files. There are two types of version control, centralized and distributed. Now, this has to be covered in the coming module, the version control, wherein we'll talk about uh, Git. We'll focus on the Git, which is a distributed version control. Because every time you're making changes to code, you're adding new things, you want to manage and you want to track those changes. Because right now you're working on code and everything is working fine. The moment you add any other change, your, let's say, application stopped working. So you wanted to move back in time. You wanted to go to a specific version and you want to use that. How is that possible? That is possible with the help of version control. Next is agile. Now, agile is one of the, SDLC model. Choosing appropriate SDLC model is also a part of your DevOps transformation journey because this will help you to achieve your quality, collaboration. So that is also an important part to select proper SDLC model. Now, software development life cycle model tells you about each and every process which is included. Now, earlier waterfall model was very popular. Okay, waterfall model. And in your waterfall model, you can see that you had these, different stages. Design stage came after the requirement stage. Development after design. So this waterfall model was considered as a rigid model. What would happen if I have 10 features? All the 10 features will be made available to the user all at once. So the team will first work on all these 10 features and then make them available to the user. Involvement of user was also very less. Involvement of the end user. And it was a rigid model. It was a rigid model because each phase needed to be completed before moving on to the next. And you cannot move back to the previous stage to make any kind of changes. That's what was happening in your waterfall model. Key characteristics were that it was a sequential and linear model. Strict documentation was needed. It was inflexible. As I said, that you cannot move back to the previous phase once it's completed. Late testing was there. because testing is done after the development phase. Bugs might not be found until the end, and making it more, costly to fix. There was no feedback loop. The model lacked the continuous feedback, and it made less, suitable for your dynamic and your evolving projects. So that's why this waterfall model was discontinued in many projects, and they moved to another kind of SDLC model like agile. Now again, there are multiple SDLC models in the market. You have different types of SDLC model, like you have agile, you have prototype model, you have RAD model, iteration model. Different models are there. And again, these things are like related to project management, so we'll not get into details of these things. We'll focus that in DevOps, the most appropriate one could be your agile. Agile was considered as a flexible model. Feedback loops were there. Your project was divided into chunks. Divided into pieces, into chunks. At a given time, you were just focusing on one thing. So let's say if you have 10 features, you'll not make all the 10 features available at once to the end user. At a given time, you will only work on one feature, and then that one feature you're going to make it available for the end user. So I had one feature here, you make it available, you develop it and you make it available for the user. You take their feedbacks, based on that, improve this feature or you add a new feature, and then you make it available for your end user. So this was your main advantage of your agile. So agile is a modern software development methodology which allows for collaboration, flexibility. And agile will focus on delivering software incrementally through the short cycles. And these are known as sprints. Short cycles called as sprints. As I said, that you will be focusing on one feature at a time. So this is nothing but your sprint. So this sprint is like your time boundary. So your sprint can be typically from 2 to 4 weeks. Okay, so let's say I have a 2 week sprint in which I'm just working on one feature. And then after the sprint is completed, I'm going to make it available for the end user. So sprint is like your short cycle at the end of which you get a deliverable. Okay, so this is your sprint. So that's why we say that in Agile, your project is divided into chunks. Your project is divided into pieces. And sprints are they are of 1 to 4 weeks. So it promotes collaboration also. Like you have uh, your daily stand-up meetings, which are mainly part of Scrum. End user involvement is more. So these are the advantages of Agile. Now, next, you must have also heard of Scrum. Now, what is the difference between Agile and Scrum? So, Scrum is a specific framework of Agile. So, when you work with Agile, you have a common frameworks of Agile. So this framework, okay, Scrum, Crystal, XP, which focuses on pair programming. These are the common frameworks of Agile. Scrum is the most popular one, is the most popular Agile framework. Now, this Scrum, this talks about the defined roles like Scrum Master, Product Owner, Development Team, daily stand ups, sprint planning, retrospectives. On the other hand, when you work on visualizing the workflow, optimize the flow of task through the process, in that case, you can work with the Kanban. This is another framework of Agile. Extreme programming, which focuses on your high quality code, continuous testing, and also focuses on practices like the pair programming, test driven development, lean software development model. In the lean, it focuses on uh, eliminating the waste, improving quality, and also delivering the fast value. On the other hand, you can also have crystal, which focuses more on like simplicity. So, your crystal, it focuses on people involved in the project and the communication between them rather than on strict processes or tools. The primary goal of your crystal is to deliver high quality software while maintaining flexibility, adaptability, team dynamics. You're focusing on the team dynamics. So crystal has lot of family of methodology. Crystal is a family of methodologies which is according to different team sizes. Like we have crystal clear, which is for 6 people. If you have a very small team of 6 people, you can go with crystal clear. If you have medium sized team, you can go with crystal yellow. For larger teams, you have orange, crystal orange. For large, if you have mission critical projects, you can go with crystal red. So these are your different frameworks basically of agile. And which one to decide is dependent completely on the requirements. Mainly, it's a part of it's a job of the stakeholders like people from project management. Next is about monitoring and logging. Okay, before starting with the next point, I can see 32 people have joined, and I'm sharing the attendance link again. Attendance link and also your LET portal access, using which you can get the recordings. Mark your attendance using your official email ID. So, in the meantime, you can mark your attendance. I'll just quickly have water. So, just give me a minute. Okay, now let's continue with the fifth point, which was monitoring and logging. So, monitoring refers to continuously tracking about the performance, the availability, and the behavior of your application, infrastructure, and the services. So, this will, your monitoring, it will help to ensure that the system is running efficiently and any kind of failure or anomaly is detected, it is going to alert your DevOps team. A key component of monitoring includes metrics, dashboards, and alerts. Metrics, you are just collecting your data, and that data is about the system's performance, CPU, memory, request rate, error rates. You can also have these visual interfaces that display your key metrics. Dashboards, you can take help of these dashboards. Anything goes wrong, you can receive the alert. So, monitoring, it actually involves collecting your real time data on the key metrics. And using this data, you make sure that your system is functioning as expected. So, monitoring is typically, proactive. And this is used to detect issues before they become critical. So, monitoring provides the real time or near real time information about the health of your system. You have different examples of monitoring tool like you have Prometheus, you have Grafana, you have Datadog. Okay, if I'll talk about use cases of monitoring is, let's say you have a server downtime. If a server goes down, monitoring tool is going to trigger the alert to inform the team so that they can investigate it. Monitoring tools can track your KPIs, okay, like response time. This will make sure that your application is running efficiently. On the other hand, logging refers to the process of recording, recording your detailed information, or simply I can say capture your information and store it somewhere. So, logging is often retrospective, which means it's used to investigate issues that have already occurred, like event records. Logs are going to record the individual events and actions, like user interactions, system error, application state change. So, logs, they store the detailed information about events that occur with an application or system, like the login attempts, application errors, user actions. Okay, and if I'll talk about use case of logging, debugging your application error. Okay, let's say if user is encountering an issue in the application. So logs can be used to find the detailed error message. Or use stack traces to diagnose and resolve the problem. So that is a use case. Why logging is important? For troubleshooting. And again, there are multiple tools for logging. Like you have uh, AWS CloudWatch logs, which is provided in AWS. In Azure, you have Azure Log Analytics workspace in which you can store the logs. Within the Azure Monitor, you can find logs and where it is collected in the Log Analytics workspace. And you can use the custom query language to query your logs. So in Azure, you have the logs which are collected in the Log Analytics workspace. And what language you can use to query these logs? You can take help of the KQL, which is custom query language to query your logs. Let's move to the next point now, which is cloud. Okay, so yeah, again using this point, what we are trying to manage, what we are trying to achieve, we are trying to achieve the key goal, which is reliability, downtime. Next is public cloud. Okay. Cloud basically. Now, cloud refers to delivery of computing services such as servers, storage, databases over the internet. Means over the cloud. Like I want to create a VM quickly. What I can simply do is I can go to the portal over the internet and I can request for the service. Want to have a storage account? I can go to the portal over the internet and I can create a storage account and I can use it for my, let's say, application for image handling. I can use that storage account. So, cloud means delivery of computing services over the internet. Now, cloud is of three types: public, private, and hybrid. Now, in the cloud, we have two things: we have deployment models and we have service type. The deployment model is of three types. We have three types of deployment model: public, private, and hybrid. Public cloud means that a cloud environment is offered by third party service provider like Azure, AWS, or Google Cloud over the internet. Infrastructure is shared across multiple customers, so multi tenancy is there, and resources can be easily scaled. Scaling is very easy in your public cloud as compared to your private cloud because physical networking, storage, that is all managed by your cloud providers in the backend. On the other hand, private cloud means a cloud environment that is used exclusively by one organization. It can be hosted on premises or by a third party provider. But the key point is that the infrastructure is dedicated to a single customer. Why to go for private cloud? Because it offers higher security and control over the data. So, in case you're concerned more about security, go with private cloud. You want more control over data, go with private cloud. You want efficiency, okay, like low cost, easier scaling, go with the public cloud. Private cloud examples like VMware vSphere based private clouds, OpenStack, or private environments built with Azure Stack. On the other hand, if you want to take the benefits of both, you might go with the hybrid approach. Hybrid means the organization can decide where the application is going to run. So, let's take an example of a healthcare organization where they are managing the medical research, data analytics, and they are storing the information of their patients in about their doctors, about the finances. So, what they can do is, in order to perform the data analytics, they can leverage the cloud, public cloud, because scaling is very easy in your public cloud. So, you also have multiple services which are available, to performing these, which makes the analysis more easy. So, here you can take help of the public cloud. And in order to store the sensitive information, they can simply make use of the private cloud. So that was your public and private and hybrid. Hybrid approach means the organizations can decide where the application will run. Now that was the deployment model. Now service type, again it is of three types. In cloud, you have three types of services: infrastructure as service, platform as service, and software as a service. Infrastructure as service means that you get the infra from your cloud providers. Okay, that is infrastructure as service. Example, virtual machines. So we can say that IaaS is getting the virtualized computing resources. Okay. Example, virtual machine. VM is example of infrastructure as service. If you want to compare it with AWS example, in AWS you have Amazon EC2. This is example of infrastructure as service. So what you manage when you create a virtual machine? What do you manage? The OS image. The updation and patching is your responsibility. And rest, the physical networking, physical hardware, that is managed by Microsoft in the backend. On the other hand, platform as a service, as the name says, that you are getting a platform. Our focus should be mainly on the development. So I am going to develop the application. So let's say I'll carry on the development. I have developed an application, I have the code and everything. Now I want to deploy it. I want to quickly deploy and manage. But also, I don't want to manage the underlying infrastructure. In that case, I can take help of platform as a service. So in this case, what will happen? You already have a service for you, which is app service instance. App service environment. No, sorry. App service instance. When you create an instance of app service, in a backend, a VM is created for you. In a backend, this virtual machine is created for you, and this is where your application will run. And you don't have access to this VM in the backend. You cannot work with the VM in the backend. And next, later, the updation and management of the VM is managed by Microsoft, not us. So, using a platform as a service, you can achieve the goal but without managing the underlying infrastructure. You need to manage the servers. Next is software as a service. In software as a service, you access the application over the internet. You access the entire application over the internet. Example, what is the example? Outlook, calendar, all these are the examples of software as a service. Now, one more example we have for software as a service, and that is Azure DevOps services, means our Azure DevOps portal. Azure DevOps services. And how do we access this Azure DevOps portal? AEX dot dev dot azure dot com. And in order to work with Azure portal, you have portal dot azure dot com, which is used to create your Azure services like VM, storage account. But in order to work with Azure DevOps, you have a separate portal that is aex.dev.azure.com. And that is considered as an example of software as a service. See, here I have a project. Okay, so here I have this project. So I have these services like boards, repos, pipelines. I can work with pipelines environment, but nowhere I'm managing the infrastructure or code. I'm not writing the code to improve the features of pipeline or to improve the features of repos. We have pipelines. In the pipeline, we can work with environment, release, library, task group, deployment group. That's it. So again, this is example of software as a service. Because in software as a service, we don't manage code, we don't manage infrastructure. We just use it. We access the application over the internet. So that was about your sixth point, which was cloud. Now, cloud is again used to achieve your efficiency because in most of the cases, cloud has made our task simple in most of the scenarios. Next is microservices. In the microservices, the application it is divided into multiple services. It is loosely coupled, unlike your monolithic architecture. In the monolithic software, it is designed to be self-contained, wherein the program's components or functions are tightly coupled. Like here, you have this e-commerce site, okay, and you have these shop UI, catalog service, SC service, discount service, order service. You have them tightly coupled. Any changes, and you will just have this one database over here. Now, if you want to make any changes to this shop UI, you need to redeploy your entire application. And any changes made to one service, it is also going to affect your other services. You need to scale just one component, you need to scale your entire application. So, this is your monolithic architecture. On the other hand, when you work with a microservices architecture, in the microservices architecture, it is loosely coupled. Okay. So I had this diagram over here. I was using this diagram for the explanation. See, this is the microservice architecture. Now here what is happening, as you can see, you have different databases. Okay, and you have these different services. Service A, this database, B, this database. And service A and service B are not connected to each other in your microservices architecture. What you do is you have these multiple backend services, service A and B. So let's say this can be your student API, this can be your faculty API, this can be some other service. Okay, let's say product API, cart API. Okay, these different services are there, and then they have their own database. And also, in front, you have an API gateway, which is used to route your request to the backend. Okay, and here we can have our client tab. So let's say we have the front end app, and request will be routed to the backend using this API gateway. Now, service A and service B are not connected to each other. So you can also enable the communication between them, synchronous or asynchronous communication. So now, what will happen if you just want to scale service A? You can simply scale service A and service B will be as it is. No changes are made to service B. So from the DevOps point of view, what benefit we have for microservices architecture? It will be more efficient because any changes have made to the service A don't need to work with service B and service C. So it allows for independent scaling and independent deployment. Now, every time, is it a good idea to go for microservices? No, it is completely dependent on your requirements. So if you are receiving, let's say, millions of requests per minute or per second, in that case, you might go with the microservice architecture. You have a complex architecture. In that case, you might go with the microservices. So here you have the characteristics. Now, microservices impact. Microservices encourage test automation for each service independently. CI/CD pipelines. Like what you can do is here, you can have the separate CI/CD pipelines. Here, what will happen? You will just have one CI/CD pipeline. Changes have to be made to shop UI, you have to get into queue. Changes have to be made to catalog service, this has to get into queue. You have to wait. On the other hand, here for service A, service B, you can have the separate CI/CD pipelines. Robust CI/CD pipelines you can create. So CI/CD pipelines can be tailored for each microservice with automated testing, code analysis, and security checks. Rollbacks, blue-green deployment becomes easier. These are the strategies, deployment strategies, modern deployment strategies. You may search about it. Or if we'll get more time, then I'll let you know about it. What is modern deployment strategy? Okay, next is infrastructure as code. The infrastructure as code means that you are managing your entire infrastructure by writing it in the form of code. Like if I go to the portal and I'll create a VM, it will take time. Similarly, if like I want to create 50 VMs, it is going to take a lot of time to create it manually one by one. Okay, here and I'll just uh, go to the networking, then management, and then configure everything. So this is not a good approach. So what we do is that we manage the infrastructure by writing it in the form of code, which also allows for reusability. I have a script, okay, you can say, or yeah, I have a template. I have a ARM template. Using this, I can deploy a VM. But if I want, I can use the same ARM template 50 times more to deploy the virtual machines. And then what else it allows? Collaboration. People can contribute to this code. They say that this configuration is not correct. They may come up to this code and they may make the changes. Collaboration, version controlling. Right now, I can create a VM or I can even go to app service. Manually, if I, let's say, try to change something, I'll just change the setting related to application inside. But the thing is that if you work with the code, you may also go with the version controlling. Okay, you are storing it in the repos, in your repository, and anytime you made the change, it will be logged. Okay, you can view it in the history. And if you wanted to move back to the previous version, you can move back to the previous version. So that's the benefit of using infrastructure as code. When you work with infrastructure as code, you may work with multiple tools which are available. But here in Easy 400, we have to focus on ARM templates and we have to focus on bicep templates. If you want to work with any third party tool, you have Terraform. Terraform can also be used for that, but it's a third party tool. So you may work with it, but right now in 400, we are not focusing on Terraform. In AZ 400, we have to focus on ARM and the bicep templates. This is covered in the separate module, infrastructure as code. Okay, so we have covered 8 points till now. Now for the ninth point, which is container, we'll continue it after a break. We'll have a short break now. And what I'll do, I'll share the timer. I'll share my screen with the timer so you can keep a track of time. And in case you have any questions, you can let me know it before going for the break. All right, so I think no questions. So in that case, I'm just sharing my screen with the timer. So I'll see you after the break. Thank you all. So your application Okay, so now let's continue with the point ninth, which is about containers. Now, containers are lightweight, portable units that package an application and its dependencies. Your binaries, libraries, configuration files, they are packed in a single unit. So, your application code plus dependencies packaged together is you can say, in a single unit, and that is your container. So, unlike your traditional VMs, containers they share the host system's kernel but remained isolated from each other, which they makes them more efficient. So, first of all, this was about the definition. Now, if you will go to this diagram over here, okay, we have this comparison between the VMs and the containers. Now, as it said that in your VMs, you don't share the host of the you don't share the kernel of the underlying operating system. In your VMs, you have the entire copies of guest operating system. So VM is actually about hardware level virtualization. So that is your hardware virtualization. Hardware level virtualization. Okay. And here in your container, it is about OS level virtualization. It's about the OS level virtualization, or this OS level virtualization is called as containerization. In your VMs, what happens that you have the entire copy of the guest operating system, and uh, your hardware level virtualization is used to run multiple operating systems in parallel. Right? And here that is done with the help of the here in the diagram you can see this hypervisor layer. So definition says that hardware level virtualization abstracts the physical hardware and creates the VMs that run independently. Each VM operates as if it has its own hardware like CPU, memory, storage, network interfaces. But in your OS level virtualization or in the containerization, this virtualizes the operating system and it creates the isolated user spaces. And these are called as containers. So these are your individual user spaces called as containers. Now here, these containers, they share the kernel of the underlying operating system. So they share the host OS kernel. And containers they run directly on host OS without additional layers. And containers are lightweight and they are faster. Now, this container will only take up resources as much as it is required. And in order to manage and run your containers, you have this container engine. So this is nothing but the software which you install. that provides you with this container engine. Example Docker. When you install Docker, it provides you with this, engine, container engine that will be help for, sharing of these resources. So managing your containers, running your containers, stopping your containers. Now, containers are also considered as lightweight, reason being because they don't have the copies of the entire operating system. It is just having the minimum binaries and libraries which are required to run the application. Rest, the sharing is done with the host of the, is done with the host OS kernel. So here I'll just write minimum binaries libraries required to run application. So now we have understood that why containers are lightweight, why they are portable. Okay, they are platform independent because once an application is containerized, it can run consistently across any environment because it has appless dependencies packed together. Can also provide scalability, speed, consistency, isolation. Now, containers have a very important thing, and that is image. So, app plus dependencies packaged together is your image. Now, in order to create an image, what is necessary? The Docker file. Docker file is very important, or you can say mandatory to create your image. So, Docker file it is added to the root of the project. Okay, or to a specific directory which contains the component that you want to containerize. So it is, you can say it's in the root of the project. So if you're containerizing the entire project, place the Docker file in the root directory. This is, most common approach for the monolithic or single service project. So here, let's say in the root of your project, you will also have the Docker file. And what is a Docker file? You can say it is nothing but like the set of instructions. So I'll just scroll here and I can see this is the Docker file. And running instance of image is a container. So image is like a blueprint and running instance of image is container. This running instance of image is container. So Docker image is a read-only template that contains application code, libraries, and dependencies, tools, and other files which are needed to run an application. Okay. On the other hand, your Docker container, it's a runnable instance of Docker image. It includes everything which is needed to run the application, isolated from the host system. So here a Docker image might include an Ubuntu operating system with an Nginx web server installed. Container is when you run this image, it creates a container that runs the Nginx server isolated from the host system. Now let's discover the common elements of the Docker file. Okay, some common instructions. So first of all, you have the base image. So your base image, you can again find it from the image library, which is Docker Hub. Here you can find the official images. Because when you want to create an image, your custom image when you want to create, it will require a base image, which is generally your runtime environment or the minimal operating system in your base image, which is the very first layer. So, how do you define this base image? Using this keyword from. This specifies your base image to use. Like here it is Node, or it can even be, let's say, Ubuntu. So, if you go to the Docker Hub, there you can find these images. Docker Hub. And here in the Docker Hub, you can also store your custom images. So let's say I wanted to search for Ubuntu and find it here. I can also search my custom images. So I created the registry and I have a custom image. Push the custom image. Here it is. Let's say Docker 101 tutorial. I can run the command docker pull this image. So, Docker Hub is like an image library where you can store all the images. You can also find the official images over there. Now, after this, after defining the first layer, which is the base image, you have the second layer, which is to create app directory. So the thing is that you are setting the working directory inside container. So in our case, user src app. This is a working directory. Next is into that working directory, you're copying all the files or directories from the host machine to the container. So in your, let's say, Node application, you have all the dependencies in package.json. So next, what you're doing is you're copying all those dependencies and then you're running the command npm install, which is used to install the dependencies. So copying your files from host machine to the container and then running the command during the build process. So using this run, you will define any command that you want to run during the build process, like installing dependencies, setting up configuration, anything. And then you are copying the rest of the application code. And then expose port, which will expose port 8080, exposes port 8080 for the app. And next is the cmd command. CMD, it specifies the command to run when the container starts. So when the container starts, you want to run this command node app.js, which is going to run your application. Okay, so we are defining this command using this array. CMD command to run the app, because this command is going to run when your container starts. And then you can also have some other, commands like add, which is similar to copy, but it also allows to fetch the files from URLs. And after that, you can set environment variables using env. So that is your Docker file. Now, how do you use a Docker file? First of all, you create this Docker file in your project. In the root of your project, you add this Docker file. After that, you run the command, which is docker build. You run the command docker build. So what are these? These are the Docker CLI commands. Docker build, then Docker run to start that container. As I said, the running instance of image is container. So for this, you can use the command docker run and the port. Okay, let's say 3000. Locally, you are running it. In case you want to save it to the image library, this image is there, you want to save it to some registry. So you can use the command docker tag and then docker push. Docker tag, because what you will do is you will also create a repository. This is your image library. In the image library, you have repositories. So you also want to push it to a particular repository, like repository ABC, repo ABC. So what you will do is you will run the command docker tag repo ABC. Let's call this image as img, docker tag img, and then docker push to push it to the image library. So let me tell you, the docker tag command is actually docker tag image name, then your username or your repository. So instead of username, I'll mention repository. And then the tag. So because you have versions, so you can follow any format 1.0.1 or V1, V2, this kind of format. Any versioning you can follow. And then you finally use the command docker push to push your image. Okay. So that was about your Docker file, how Docker file is used. And then when you create the image, the running instance of image is the container. Now, instead of storing it in the Docker Hub, your images, you can store it in the image library, which is Docker Hub. Other than Docker Hub, you also have the option to work with ACR as your container registry. Now, let me tell you the most, you can say, used services in Azure for working with the containerized applications. So, first of all, you have the ACR, which is used to store the images. ACR is used to store the images privately. Next is you can work with Azure container instances. Azure container instance is used to run your containerized applications. But that too, if it is only a single image, only one single container you can run. Only one image you can use. So generally what it is used for, it is used for short-lived batch jobs. Background processes. For that you go with the ACI instance. Okay, next is Azure Kubernetes services. This is used when you have complex requirements. Okay, let's say microservices architecture, auto scaling, auto healing that you need. In that case, you work with the Kubernetes, Azure Kubernetes. In that case, you go with the Kubernetes architecture because here you need multiple container images. So, how can you define that? Using a YAML file. Using the YAML file, you can define the configuration of your Kubernetes cluster. So, what happens is that you have a cluster, Kubernetes cluster, you have multiple nodes, and within the nodes, you have pods. And pods actually have your containers running. Okay, so this is your pod. You have nodes, node 1, node 2. Node is nothing but the VM. This is your cluster. So for auto scaling, you will define how many instances you want to have, how many nodes you want to have in order to distribute your, traffic. And then within the pods, you have these containers running. So this kind of complex requirement, if you have, in that case, you go with the Kubernetes. And how do you define the configuration of this Kubernetes cluster? This configuration is defined using the YAML script. So how many containers you want? How do you manage the internal communication? All those things are managed with the help of the YAML script. Next is Azure Container Apps. Again, Azure Container Apps are also used for managing, microservices based architecture. But the thing is that Azure Container Apps follows the serverless approach. So Azure Container App is a serverless container service, which will allow you to run your microservices and containerized application in the cloud. But you are not going to manage the infrastructure. It will abstract the underlying infrastructure. So this will provide you a simple way to deploy and manage your applications. So key feature is that it follows the serverless approach. You only pay for the resources that you use. And it also supports CADA for the event driven scaling. So it allows the serverless. Serverless means how many nodes will increase or decrease, you will not manage. It will increase based on the request. Okay. And you will pay for what you use. That's it. If no requirement, nodes can go to zero. But in Kubernetes, you have to define the scaling, how scaling will be done, scaling rule. So serverless, and here also it supports CADA, which is Kubernetes event driven auto scaling for event driven scaling. Next is it has ingress support. So you can easily expose HTTP based application with built-in ingress for secure external access. You can enable or disable the versionings, okay, or we call it as revisions. So you can enable or disable the revisions to manage your application updates or rollbacks. So if you have multiple versions, they are known as revisions. So you can manage this versioning. Okay. So that is the main, your features of your container apps. Let me show you CADA also. Event driven auto scaling. CADA is a Kubernetes based event driven auto scaler. With CADA, you can drive the scaling of any container in Kubernetes based on the number of events needing to be processed. So in the backend, this is integrated with the CADA. So yeah, sorry, with the built-in auto-scaling, when you have microservices, you want to host RESTful APIs with the built-in auto-scaling, or you need to have event-driven processing. Like you want to use event triggers like messages from Azure Service Bus to process your workloads. If you want to deploy single page applications, then also you can go with the container apps. You want to have background tasks, so you can also run schedule jobs. You can also have this sidecar. In container apps, we have the concept of sidecar also. Like a sidecar you can add which will be responsible for logging. So in container apps, you have environment. Within the environment, you have container apps. And then you can also have these sidecars, which may do the background task like logging. So this is environment, container app, another container app, sidecar, and then you can also manage the internal communication. You can take help of Dapper also, the Dapper APIs. Now see if you want to know more about it. It is already covered in your 204. It's not a part of 400 basically, but a part of 204. So in case you want to know more about it, I'll just share this 204 documentation with you. Implement containerized solution. This is a separate module in 204. So in case you want to know more about it, please refer to this. Okay, so there is a question that what is the main difference between AKS and container apps? See, in container apps, you are not managing the underlying infrastructure. Okay, on the other hand, in the AKS, you have to manage this underlying infrastructure. Okay, both are your services for running the containerized application. But use cases and the level of complexity is different. Like uh, your container apps. Your container apps, they follow the serverless approach. They are integrated with the CADA in the backend. So it can also automatically scale down to zero when it is not in use. In AKS, you need to handle the scaling. You need to go for manual or the rule based auto scaling. Networking. Now in AKS, you have advanced networking capabilities. You can go for VNet integration, load balancers, ingress controllers. On the other hand, Azure container apps, they have a simplified networking. They have the support for HTTP traffic. AKS will provide you high level of customization. So you can configure node pools, security policies, storage. So AKS, in order to handle AKS, you also need, a proper DevOps team for if you want to manage the AKS clusters. On the other hand, for ACA, if you're let's say just starting and you don't have a very skilled people, okay, in that case, they may also be able to work with the ACA because customization is limited. So and also you're not focusing on the infrastructure, the detailed infrastructure configuration, you're not focusing on that. AKS uh, are suitable for containerized applications like your stateful applications, machine learning models. ACA, if you have like simple microservices, REST APIs, event driven apps, you might go with the Azure Container Apps. Okay, so that is the main difference. Let me see if there is any proper documentation by Microsoft for their comparison. If this link is not working, let me see if any other useful link is there. AKS, ACA. Okay, yes, this table will be useful for you. Now, also one more thing that in AZ400, we are not working with the Kubernetes clusters or even the Azure Container Apps. This was just to make you familiar with the services in Azure which are used to run your containerized application. In the labs, in everything, in all the modules, we will be taking help of Azure App Service to work with the containerized applications. But this was just to make you familiar that what all services in Azure are actually there. So here, what I wanted to say, I just forgot. Yes, about the learning path. See, if you want to learn about Azure Kubernetes, now for Azure Kubernetes, they have created a separate learning path. It's a 50-day learning path. So Kubernetes is not something which you can learn in 5 hours or 5 days. You need like 50 days to learn Kubernetes. It's a very, vast topic. So Kubernetes is not a part of 204. Kubernetes is not a part of 104. In those courses also, like they have just removed Kubernetes. So if you want to go through the learning path, you need to learn about Kubernetes. So in that case, they have Azure Kubernetes Zero to Hero, Kubernetes Learning and Training. You can download the learning path. This is your learning path. How service meshes work in Kubernetes, how pods and the pod lifecycle work in Kubernetes, what has to be done on day 15, 16. So just click on it and study about it. So this is your Kubernetes 50-day learning path. Or you can also go to the GitHub. Here also they have mentioned this learning path. What all has to be done on day 1, day 2. Now to publish your containerized applications, you can also use app service. So in your app service, you can, choose that what you want to publish. You want to publish code or you want to publish container. Let's see if I'll go to the app service and here click on create. And here you will find that you can publish code or you can publish container. And if you select container, you will select the image information. You can use your own images, let's say from Azure Container Registry or other registries, okay, like this. And also you can use the quick start images. And here also it is supporting the sidecars. As I said, that you can have the enhanced configuration with the sidecars. So you can include the sidecars also. You can learn more about the sidecars. Sidecar support enabled. Then you can add the sidecar container, image information, everything you will add here. Here, what they are doing, they are marking main container as main and sidecar container as sidecar. Now, if I'll go to ACI instance, when you will create a container instance, at that time also you will get the information to add the image. See which image you have to use. And again, you can only select one image. You cannot select multiple images. Only one image you can select here. So generally this container instance is used for the short-lived batch jobs. Now again, let's say you have a simple e-commerce application and you don't require these complex requirements like microservices based. So you just have a simple e-commerce web app. So what you will select, ACI or ACA? The answer is app Azure App Service mainly. Because container instance is mostly for the background jobs. So if you want to make your application up for 24/7, you want to make it available for the users. So you generally go with the app service. Now again, things cannot be decided like this way. You need to go through the requirements and then decide it. So again, I have a good article for this, which tells you the difference between container apps and your app service. Container instances and app service. So here they are discussing in detail some advantages of each service and disadvantage. And ultimately, what all you have to consider when you want to select a particular service. So these are the services in Azure which are used to work with the containerized applications. And to store the images, you work with the ACR instance, Azure Container Registry. So that is your transformation journey. This was about your transformation journey. Now let's see the services in Azure DevOps. Let's discuss their life cycle. So you have some end users over here. Okay, they have some requirements, and their requirements will be gathered by the stakeholders. Now these stakeholders, they are going to gather the requirements, collect it. Now what they'll do next is that they have to start with the planning. The project planning they will focus on. So project planning. Now as you know that there are so many tools which are available, which are used for the planning. Like ServiceNow, we have Monday. Now in Azure DevOps, we have a service known as Azure Board, which is used to manage, your work items. So mainly it is used for the planning. Azure Board is used for planning. Now next is that once they have like added the work item, they have added the task, they are going to assign the task. Okay. So here I'll add a work item will be assigned to the team members. So task is going to be assigned to the developer or other tasks which are related to infrastructure to the infrastructure team, DevOps team. So, you'll work items will be assigned. So basically, work is going to be assigned to your team. Now, this team is going to make changes to the code. They are going to contribute to the code base. And here it can be stored, your code can be stored in the GitHub or in the Azure repos. You have GitHub. Similarly, in Azure, you have Azure repos. Okay, you have the Azure repos. Now, next is that this is the raw code. Now we need a build step in the pipeline. So what we are going to do now is we are going to create the pipeline because we want to convert the high level programming code which is written in, let's say, Java or C sharp. We want to convert it to executable code or bytecode, which ultimately the machine is going to understand. So here I'm going to add the build step. So for that, I'm going to take the help of Azure pipelines. Here I can have the build step and also the test step, which is an important part of the CI process. So how I'm going to create it using the service as your pipeline. Now next is that as a part of this build step, I'm going to get the output, which will be like executables or the bytecodes. So here I'm going to get the output. And this output will be ultimately used in the CD process, will be ultimately used in the deployment. Now, the thing is that I don't want to deploy this artifact directly to the production. So we will have a testing stage also. So, these are the different stages, and that is again different for different projects and organization. SIT stage, you have UAT stage, QA. Okay, so right now for the simplicity, we are just adding two stages, testing and production. So here I can have, let's say, multiple instances. This is instance one, which is for testing, and this is the another instance. Okay, so here we'll work with the different Azure services. And here also we'll take the help of the pipelines to create this CD pipeline. Here what we are doing, we are working with the CD pipeline. CI and CD pipeline we will be creating. Next, for the package management, if we are working with the packages and you want to have a private feed in which you can store your custom packages, you will take help of the Azure artifact. Can be used for package management. Okay. So that's how we are going to discuss the things one by one. Firstly, we'll start off with Azure boards, then we'll move to Azure repos, then to the pipeline, and then to DevSecOps, the security, and then the Azure artifact. Now, first of all, what we have to discuss now, we have to discuss the Azure boards. We will be discussing Azure boards. It is used for the planning. We plan the work items. What are the different types of work items? So, first of all, we can have the epic. What is the epic? Epic is a high level requirement. Example, I want to um, create a web app. That can be the epic. Next is Now, in order to create web app, we cannot just go and simply create it. We have so many features which are included in that. One by one, we focus on the features. So next, we can say that our epic is further divided into features. Okay, let's say I want to have I want to manage the login. So basically, I want to manage user registration. User can sign in, and if not, they can register and then they can sign in. Next is your feature is then divided to user story, or you can say the product backlog, which is like a to-do list. So as a user, so user stories are written from the user point of view. So as a user, I want to I want to sign in using my Google account. Okay. Now this is a kind of to do, or you can say roadmap which you have created. Now this user story is further divided into configurable, which is your task. And this task is assigned to the individual, uh, you can say team members. Like you can have a login form, you have to implement the backend logic. So all these things are your task, and then these tasks are assigned to your team members. You can say to develop. Or if you have any task which is for your infrastructure, you will assign it to your infrastructure team. Next, you will also have the bugs. So, what are your bugs? The technical errors. Okay, then you have impediments. Impediments are your uh, errors. Not sorry, not errors. You can say hindrance. Technical or non-technical. Now, how we are going to work with this work items? So, in Azure Board, what happens that when you create a project, you select a template. While you create a project, you select a template. And based on the template, it is decided that what work items you are going to work with. Example, you select a basic template. Let's say you have selected a basic template. In that case, you will work with only three things: epic, issue, and task. You can also have other templates like Scrum, Agile, and CMMI. So these are the four templates which are there by default. If you want to create any other template, you can create an inherited process in which you can add the custom work items. But by default, four are there: basic, Scrum, Agile, and CMMI. See, if I'll go to the project, so first of all, in the DevOps, what is the hierarchy? You have the organization, and within the organization, you have the projects. In your DevOps account, you can have multiple organizations. See, these are the organizations, and then you have the projects that you work with. So I'll create a new project, and that will be Wipro. And then I'm going to select the visibility. I want to make this project as public or private. Click on advanced and then click on work item process. See agile, basic and scrum. And these are the ones which I created, the custom ones. So for now, I'm going to select basic. I can create it. Now here I can go to the boards to manage my project, to add the work items, but I can work only with three: epic, issue, and task. If I want to work with, let's say, user stories, so in that case, I need to select the appropriate template. So is your default processes, default processes and process template in Azure board. See, if you want to work with Agile, you will get epic feature, user story, and the task. And then the configurable ones are bug and task. Scrum, in Scrum, you have epic feature and then the product backlog item, which is like a roadmap. It's like a to do. And then, in order to achieve that, you have the task, which will be completed by the team members. And then for issue tracking, you have impediment. CMMI, it is for, making the changes, reviewing. If you have a project, you want to go for the risk management, changes. So for that, you have the CMMI template. So I'm sharing it with you. Yes, you can say that as your board is, similar to Jira because that is also used for the management. And here also we are using it for managing the work items, assigning the task to the team members. But it's not like exactly it will be same. You can compare it. Because again, if we talk about DevOps, DevOps is not about tools. It's about, your principles and your concepts. Because again, for if you talk about pipeline also, in case of pipeline also, you can take help of Azure pipelines to create this CI/CD pipeline. But again, there are a lot of other tools. Like for creating the pipelines, you can work with Jenkins, you can work with Bamboo. For creating CD pipeline, you might work with Argo CD or again Jenkins. Okay, so if you talk about DevOps, there are hundreds of tools to implement the same thing. So it's not possible to be like familiar with each and every tool, and that is completely fine. Okay, so now what I wanted to do here, I want to change the work item. Sorry, I want to change my project, which is this one, to let's say Scrum. So I'll go to boards. I'll go to projects and I can see the basic projects. See Wipro December. Can I change the template? Yes, I can change it. Click on change process and select your target process. That will be, let's say, Scrum. But there is a warning that after changing your process, you must manually update your work items. Because if you're, let's say, changing from Scrum to basic, in Scrum you have, let's say, here is Scrum, you have impediment, but that you don't have in the basic. So you need to manually update your source first so that your project doesn't look broken. Because if you'll try to change this way, it will show you the warning. It will throw you the error. Sorry. Not even warning, error. Now it is updated. I can go back here, go to project settings, sorry, to boards and see work item. And now I can see bug, epic, feature, impediment, product backlog item. So now let's try to add a epic, which is a high level requirement. Let's say implement web app. Now you can add the start date and the target date, priority, effort, and the value area. It is adding value to your business or to your architecture. Save it. Now you can also manage your feature, say user registration, and now the task. But one more thing to manage here is the iteration. Because as we said that, in Agile, your work is divided into chunks. So you work, in sprints or iterations. There's a time boundary. So you will go to project settings and you will go to, see if you go to project configuration, you can manage your iterations and areas. Go to team configuration, iteration, areas, and templates. See, areas is you have a project and that is divided into multiple areas like infrastructure development. So you can add these areas from here. You can add the child, a new area name. Let's say that is development. And also change the iteration. So you have just one iteration and that is sprint one. You can add the another sprint also. So now what I can do, if I'll add the work item, see I can also select the areas from here, the states of the work items. And here I'll add the work item feature. I can select the sprint. Let's edit this. Okay, from here, you can select the area development, and let's say the iteration, which was sprint 1. Okay, from 9th to 16. Okay, so you can select the sprint for the work item. An area, I'll just keep it as Wipro, not the development or infra, and just save it. Now, next is you can go to the backlogs. It's a place where you can manage all your work items. So, what I'll do here is I'll create the new work item. So, here you can also select the navigation. Me enable it. Why that sprint is not coming up over here? I think it's because of the other template which I have selected. Maybe the UI has been changed. So I'll just do one thing. I'll go back to the organization settings and I'll go to the process. Okay, it does not contain product backlog item. Okay, just give me a second because this is also Scrum project. And if I go to backlog here, I can view all the sprints. And I can just drag it and drop it like this. To sprint 3, I can move it into sprint 2. Okay, now it came up over here. Alright, so I just added the sprint and now it is visible over here. What I can do is I can also add another sprint, which is sprint 2, to backlogs. Okay. Now what I can do is I have the product backlog 1 and within that we have the task and task has been assigned to Joseph Price and this is the iteration and you can see that in task 1 your product backlog 1 is the parent because we are creating directly from the here from the backlog. But if you go to work items and if you will have a look at the user registration, no parent is selected for user registration. Child is selected but not parent. So you can also add an existing work item as parent. Reason being because we have not created the user registration from the backlogs. We created it separately, epic and the feature. So parent will be the epic and that will be implement web app. Click OK and save it. Now if you want to view the entire hierarchy, in that case what you can do, see, go to epic, then you have feature, within that you have product backlog, then the task. You can also add another task from here. This can be task 2. You can save it. Within the feature, you can also configure the another product backlog item. This is your hierarchy. And see in the sprint 1, you are working on 2 product backlog items and 2 tasks. For here also, I can add the task. That's how you work with your work items. And then what you can do is you can go to the sprint or directly from here you can click on the sprint 1 and go to the task board to visualize your progress. See, move to in progress, done. Now you can assign this task to also to some person. Let's say Joseph Price only. Okay, and now you can also find the, you can also add the time that it would take. So let's say 20 hours, and here it would take 20 hours. Okay, just, for the example. Now, how you can manage the team capacity. So for that, you can go to capacity and you will define that your team members for how much time they are going to work. So Joseph Price is there and he can only work for 8 hours per day. And Anna Green can work for 8 hours per day. So total, which means sprint is for 5 days. So means that both of them will be working for 40 hours. So if you go to task board and you go to people, okay, not people, let's go to work details and here you will find the work details. So right now it is fine. Anna Green had the capacity for working of 40 hours, but she is working 20 hours. And Joseph Price is working for 40 hours. But the moment I will increase the limit, it will be highlighted in red. So it's important to manage the task efficiently across your team. So from work details, you can view it. You can balance the work across your team. Okay, so that was about your Azure boards work items. Next is you can also run the queries. Click on add new query. I want to find out about the active bugs. Work item, bug. State any. State can be, let's say, any accepted, closed, approved, and run it. You can also run the query and you can save it across my folder or the shared folder. You also want to search for work item assigned to some particular person or to yourself, assigned to, let's say, Hannah. For future, you can save this query so you don't have to run it again and again. Work assigned to Anna. Save it in a folder, my queries or shared queries. So for yeah, here now you have this query saved. If you'll go to queries, you will go to work assigned to Anna. Okay, you will have this query saved here. Click on it and you will view the result. So every time you don't need to, configure the query. So that was about your Azure boards. Okay, if you have any question till here, do let me know. I'm sharing the attendance link also. Now let me just give you the idea of labs. Okay, so I'll just share the link with you for the labs. Just give me 1 minute. And it is to go with right. So you will see here that you have labs. If you'll scroll down, see different labs are there. And each lab is having 10 launches. Okay, so for every lab you have 10 launches available.
Yeah.
Okay. And expected duration is of 2 hours. But this lab will take around 60 minutes to get completed. Okay, so each lab is having the 10 launches. After this step, what you have to do is when you click on launch, you will find the username and ID that you will be using to sign in to Azure portal. So do you want to launch the lab right now?
Do you want to launch this? Hi,
Yes, you
Sudhika.
can. How it is done in using those same again time is he is taking the link and the training key again. Okay, so first of all, you have to right hand side icon track of the start a web browser, create your profile and continue. Here you have to create your new. Okay, now here you have to create your new organization. Continue. Make sure that after step 2, when you are signing, Okay, when you're signing into Azure DevOps organization, make sure to go to resources and use this username and password. Okay, and now this is our newly created organization with a project eShop on web. Project is also there by default. So I think you don't need to create new project because earlier when Azure Pass was used, you have to like create everything from the scratch. So I think this project is already created for you. Yes, eShop on web, and you don't need to create it. Open eShop on web project. Okay, so it's already created for you. You don't need to create project. So now what they're asking you to do, they're asking you to select service connection under pipelines. Now we have to create the service connection. Okay. So what is a service connection? Though I cover it on, after working with the Azure boards, because generally, when earlier we were using Azure Pass, there was no need to create service connection in the very beginning. But I'll tell you what a service connection is. Service connection is used to, is used to create connection with the external services. Like you are creating a pipeline and you want to work with Docker registry. You want to create an image and you want to push that image to the Docker registry. So when you want to push it to the Docker registry, you need to first create a service connection. Okay, so I am inside the project, and in the project you will click here. This is the project settings. Okay, just click on it. Project settings. Click on this show side menu, and here you have the service connections under the pipelines. Click on service connection and create service connection. So as I said that if you want to get connected to Jenkins, or you want to get connected to Kubernetes cluster, click on Kubernetes and then you will mention the details like your authentication method. So service connection basically contains these details, okay, like your passwords, tokens. So here, if you want to get connected to Docker registry, click on Docker registry, click on next, and then your registry, Docker ID, and password. And later in the pipelines, you can use this service connection to push the image to this registry. Right now, they are asking you to create a service connection as your resource manager service connection. Select app registration from the identity type. Okay, select app registration automatic. Select workload identity federation and subscription under the scope level. Okay, workload identity federation and scope. So actually what we are doing right now, we are creating a connection from the DevOps portal to the Azure subscription, because ultimately we have to create the resources within the subscription or within the resource group. Scope you will decide. Because if you're taking help of app service instance, that app service instance is in Azure. Okay. So you will first create a connection from your DevOps portal to your subscription to which you want to deploy. So right now, my subscription is selected. This is my resource group and the service connection name, which is Azure subscription, and then save it. So in the backend, what is happening? We are using the service principal. Okay. So I'm getting this error. You do not have permission to create service connection. You need to be a creator for service connections in this project, but you can create it manually. Let me try again, or we have to create it manually. Because what happens here is that in the backend, the service principal is created for us. Okay, let me try it manually. Okay, this is also not working here. The manual option. I think I need to look into this because earlier, we are not following this approach. What we did was we just went to project settings, and this is how it looked like. Let me see if it has been changed here also. Click on next. See, you just have to select service principal automatic. Click on next, and then you have to select your scope. Here, select your resource group. Service connection name, and the service connection would have been created. Is your past December? Okay, the service connection is created. So that's how we used to do it. So I need to look into this. That what all we have to manage here. Let me click on save. Okay, I need to look into this error. Okay, because things have changed on how to create the service connection. I'm getting this error, don't know why. So I'll do one thing, I'll just look into this and tomorrow I will let you know. From your side also, if you want to launch the lab and you want to try it, you may do so. Okay, because I think in Azure boards you don't require this service connection because this is only about managing the work items. Okay, so once you complete the lab, you can just end your lab and mark it as completed, or you can cancel your lab. So that I'll let you know that why that error was coming. All right. So yeah, one thing you can do is that is to redeem the training key. Okay. Any other questions till here about any topic that we have discussed other than